All right, one more example that I want to show you. We'll essentially be doing the same thing that we've done in the last couple of examples. It'll just be starting out with a different function here. So the algebra that we'll do will look or feel a little bit different. Fortunately, just like the previous few examples, the algebraic tricks necessary to figure out the derivative of this function will be tricks that you've seen before back in the average rate of change section. Without further ado, here's my function. F of x equals x divided by x minus 2. This is what's called a rational function because it kind of looks like a fraction. And it's an interesting function. This function has a vertical asymptote at 2. It's got an x-intercept and a y-intercept at 0. It appears to go through this point 3, 3. You may have studied functions like this in a pre-calculus class, but really none of that matters. We don't need to use the graph at all for this example. All we need is the function algebraically. However, just like I have in the previous videos, I want to give you the graph to try to tie these ideas together in your head. So the first question is to determine f prime of 3. First, make sure you understand what that's asking. In terms of the graph, that's asking for the slope of the tangent line at the point where x equals 3. When x equals 3, coincidentally, the y value also equals 3, which is why this point 3, 3 is on this graph. Picture in your head what the tangent line would look like. Hopefully you're picturing something that looks more or less like this. What is the slope of this line in green? I don't know because I just kind of freehand sketched this tangent line. It's definitely some negative number, but what negative number? I'm not sure, like maybe -2 or so. It's hard to tell from this rough drawing, but we can figure it out exactly by using algebra. So let's do it. Let's calculate f prime of 3. To calculate f prime of 3, we want to evaluate a limit, specifically the limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h. These are the y coordinates of two different points. One of them is at 3, right here, pictured in green. The other one is at 3 plus h. So in your head, maybe you can picture it like right here or something. It's a little bit to the right of 3, depending on what h is equal to. I like to consider h as a positive number. It makes it easier. To calculate the slope of the secant line between these 2 points, we find the change in their y coordinates divided by the change in their x coordinates. Their x coordinates are 3 plus h and 3 respectively. When we do 3 plus h minus 3, we're left with just an h. So this is kind of the simplification of the average rate of change formula. If h is the positive number that puts this second point over here, my secant line would look something like this. Close, but not super close to my tangent line. But as we let h get close to 0, this second point gets infinitely close to this first point, so that the slope of the secant line gets infinitely close to the slope of the tangent line. So when we evaluate this limit, we get the slope of the tangent line. You're like, yeah, I get the point. Just show me the algebra. All right, sorry. The function is x divided by x minus 2. So to figure out f of 3 plus h, I want to copy this exact expression, x over x minus 2, except I want to change all the x's into 3 plus h's. So I'll have 3 plus h divided by 3 plus h minus 2. From that, I want to subtract f of 3. Again, changing all the x's into 3's, I would get 3 divided by 3 minus 2. And then I want to take that difference and divide it by h, and as I often do, I forgot to put in the limit here. It's good to note that this is really the limit as h approaches 0 of this expression. How do we simplify this expression? Simplify it to the point where this h cancels out so that we can change all the h's into zeros. Well, we got some fractions inside fractions. Maybe you remember the trick for that. We want to make it a single fraction over another fraction, and then the way you divide fractions is by multiplying by the reciprocal of the denominator. But I'm kind of getting ahead of myself. Let me simplify this a little bit first. This 3 and this -2 just leave me with 1. So this fraction here is really just 3 plus h divided by 1 plus h. And since 3 minus 2 is just 1, this fraction here is just 3 divided by 1. And then the bottom I got an h, which I'm going to write as h over 1. Yes, this 3 over 1 is just 3, so I could have just written a 3 here. And yes, h over 1 is just h, so it might seem kind of silly to write it this way. But I did that on purpose because I want to have a fraction divided by a fraction so I can flip stuff upside down. Maybe you remember that trick. I'm almost there, except right now I have 2 fractions up top, not 1 fraction. So what I got to do is kind of mash these 2 together and make them a single fraction. How do I do that? Well, the way you subtract fractions is you need a common denominator. So what I got to do is multiply the top and the bottom of this fraction here by 1 plus h, because that will give me a common denominator between these 2 fractions. Note that I did the multiplication to the top and the bottom of this fraction so that I wouldn't change the value of this thing. This is the same as this, which is the same as the number 3, which is the same as 3 times 1 plus h divided by 1 plus h. but writing the number 3 in this form is beneficial because now I can do my subtraction. I got the limit as h approaches 0 of, on the bottom, I just have h over 1, and on the top, I'm subtracting two fractions that both have the same denominator. The denominator is 1 plus h. And when you're subtracting fractions that have the same denominator, you just write the denominator one time, and you subtract their numerators. So I got 3 plus h minus 3 times 1 plus h. If you have a hard time going from here down here, think about this like it's, 6 sevenths minus 2 sevenths. You don't subtract the 7s on the bottom, you subtract the 6 and the 2 up top to get 4, and write 4 sevenths as the difference. That's kind of the same idea of what I'm doing here. Maybe I'm just making it harder. Let me continue. I got the limit as h approaches 0 of, if I take this negative 3 and distribute it through, I get negative 3 minus 3h. The positive 3 and the negative 3 cancel out. The 1h and the negative 3h net out to negative 2h. So in the numerator, I got negative 2h over 1 plus h. And in the denominator, I got h over 1. This is the bad h, the one that I'm trying to get rid of. But fortunately, now I can get rid of it. The way I'm going to do it is I'm going to change this quotient of fractions into a product of fractions by taking the fraction down on the bottom and flipping it upside down. So instead of negative 2h divided by 1 plus h divided by h over 1, I'm going to take negative 2h divided by 1 plus h, and I'm going to multiply it by 1 over h. This h in the numerator and this h in the denominator cancel each other out, which is great news because that leaves me the limit as h approaches 0 of negative 2 divided by 1 plus h. There's still an h in the denominator, but it's a good h. It's not this bad h. This bad h canceled out with this h. What made this h bad is that if I changed all the h's into zeros to evaluate the limit, it would cause me to divide by 0. But this h does not. If I change all the h's into zeros here, I get 1 plus 0, which is not 0, it's 1. This limit is negative 2 divided by 1, in other words, negative 2. The slope of the tangent line to this red curve at this point in blue, the slope of this line pictured in green, is exactly negative 2. Now that I know the right answer, I can redraw this tangent line a little bit more neat so we can really see that slope of negative 2. We go down 2 units each time we go right 1 unit. F prime of 3 is negative 2, which is cool and all. It's good for you to be able to calculate this, but what will be more important in this class is calculating f prime of x, not f prime of 3. Good news, these steps that we did here, the fractions inside fractions and common denominators and flipping stuff upside down, is exactly what we're going to do here. Great place to test yourself. See if you can calculate f prime of x. If you're not sure you can do it, see if you can just set it up. See if you can get to the equivalent of this line right here, and then start watching the video again. To figure out f prime of x, I want to evaluate a limit. The limit as h approaches 0. The limit as h approaches 0 of f of x plus h minus f of x divided by h. A lot like what you see right here, except instead of 3 in these two spots, I got an x in these two spots. And because I have this function f of x defined right here, I can figure out f of x plus h and copy down what f of x is equal to. Since f of x is x over x minus 2, f of x plus h would be x plus h divided by x plus h minus 2. From that, I want to subtract f of x, which, as I said a second ago, is x over x minus 2. And then I want to divide that whole thing by h. Things are going to get a little ugly here, so I want to make sure I leave myself plenty of room. What I've copied on this line is identical to what you see here, just kind of spread out a little bit. The reason I wanted to spread it out is because my next step involves subtracting these two fractions, changing these two fractions up in the numerator into a single fraction. And that's hard to do because they have different denominators. So what I need is for them to have a common denominator. And if you look at them, you might be like x minus 2, x plus h minus 2. They're so close, I'm just missing the h over here. Why don't we, add h to the top and bottom? You can't add a number to the top and the bottom of a fraction without changing its value. You can only multiply the top and the bottom of a fraction by a number to avoid changing its value. And you're like, okay, so what do I multiply this by to turn it into x plus h minus 2? The answer is there's nothing you can multiply it by to change it into x plus h minus 2. However, what I could do is I can multiply this side by x plus h minus 2. And if I'm going to do it on the bottom, I better also do it on the top, x plus h minus 2. And you're like, no, you messed up. Now over here, your denominator is the product of these two things. It's not the same as just x plus h minus 2. That's true, but I can multiply this side by x minus 2. Again, making sure to do it on the top and the bottom. If you look at this huge mess that I have here, the denominators are the exact same. They're both the product of x minus 2 and x plus h minus 2. Since I have the same denominator, I can do some subtraction. Before I do any subtraction though, I'm going to clean things up a little bit, because I can already see this algebra getting pretty intense. Up in the top here, I'm going to have to FOIL stuff out. So I'm going to have to do x plus h times x minus 2 at some point, so I might as well do it now. This x times this x gives me x squared. This x times this negative 2 gives me negative 2x. This h times this x gives me hx. And this h times this negative 2 gives me negative 2h. The denominator for that is the product of these two terms, which I don't have to FOIL out. You might wonder how I know that I don't have to FOIL out these two terms. The short answer is because I've done these problems so many times, because I've taught this class a bunch of times. But maybe a better answer is because the only reason I'm algebraically manipulating this mess is so I can get rid of this h on the bottom, right? Getting rid of this h on the bottom is my main goal. And the way I'm going to get rid of this h on the bottom is I'm going to write it as h over 1, and then I'm going to flip it upside down. So I'm going to end up with the product of two different fractions. The fraction that's on the top and 1 over h. So this h that's on the bottom is going to have to cancel with an h that's in the top of the fraction that's up on the top. So really it's just the top of the fraction that's up on the top that I need to simplify as much as I can, because that's where the h is going to come from that cancels with this h right here. Follow all that? Probably not, but that's okay. Just like I got rid of the parentheses over here on the top, I got to get rid of the parentheses over here on the top. If I take the x and distribute it through, I get x squared, this x times this x, plus x times h, this x times this h, minus 2x from this x times this negative 2. And the denominator, I'll just write it a little bit differently, x plus h minus 2 times x minus 2. The same thing you have written here, just in a different order, because multiplication is commutative, but now it looks more like what it looks like over here. You can see the common denominator a little bit better. This is ugly, this is a mess, this is a disaster, but it's about to get a lot prettier. Nothing really to do on the bottom. Maybe we'll just change this h into h over 1 so that it looks like a fraction. But up in the top here, since I have a common denominator, I can subtract the numerators of these fractions. I can make these two fractions a single fraction. The denominator for that single fraction will be x plus h minus 2 times x minus 2. The numerator for that fraction will be this stuff minus this stuff. But look what happens when I take this stuff and I subtract this stuff. I got an x squared minus an x squared. Those are going to cancel out. I got an h times x minus an x times h. Those are the exact same thing. Those are going to cancel out. I got a negative 2x minus another negative 2x. Those are going to cancel out. Of the 7 total terms that I have up top, 4 over here and 3 over here, 6 of those 7 cancel out. Things are getting really nice. All that I'm left with in the numerator is a negative 2h. I now have a fraction divided by a fraction, so I can do my little trick where I divide fractions by multiplying by the reciprocal of the denominator. I take what's up top and just write it again. Negative 2h divided by x plus h minus 2 times x minus 2. And then instead of dividing by h over 1, I'm going to multiply by 1 over h. Dividing by a number is the same as multiplying by its reciprocal. Dividing by 3 is the same as multiplying by 1/3. But by writing it this way, it's easier to see that this h and this h are going to cancel out, and what I'm left with is just the limit as h approaches 0 of negative 2 divided by x plus h minus 2 times x minus 2. The good thing about this limit is it's easy to evaluate. I can change all the h's into zeros. I couldn't do that up here, because if I change all the h's into zeros up here, I'm dividing by 0. But down here, if I change all the h's into zeros, I get negative 2 divided by x minus 2, because this h is a 0, times x minus 2. In other words, I get negative 2 divided by x minus 2 squared. F prime of x is equal to negative 2 over x minus 2 squared. In some sense, this function, x over x minus 2, is very closely related to this function, negative 2 divided by x minus 2 squared. This machine encodes all sorts of information about this machine. It encodes the slope, the rate of change of this machine. I can use this machine to verify things like my answer to part A. I could figure out f prime of 3 much easier now since I have this rule. All I got to do is change all the x's into 3's. I got negative 2 divided by 3 minus 2 squared. 3 minus 2 is 1. 1 squared is 1. So I got negative 2 over 1. In other words, negative 2. The same answer I came up with over here. But maybe more interestingly, if I go back to the graph of my original function f of x here, maybe we'll take a look at it in Desmos. I see it pictured in red. Think about what the graph of the derivative of this function should look like. When I get way out to the right on my graph, it looks like the graph is getting really close to a horizontal line, which has a slope of 0. Similarly, when I go way to the left, it's getting similar to a horizontal line. So what I think should happen when I look at the derivative is the height of the derivative should be close to 0 when I go way to the left and way to the right. But an interesting thing will happen in the middle. I have this vertical asymptote. So when I get really close to this vertical asymptote, this graph has a really large negative number for its slope, right? It's going down really, really quick over here. And similarly on this side, it's going down really, really quick. It's got a really large negative slope. So what should that look like when I graph it? Well, I know the equation. It's negative 2 over x minus 2 squared. So all I got to do is take a look at that graph. Here it is. Does the graph in blue match up with what you expected the graph in blue to look like? Can you see how the graph in blue represents the derivative of the graph in red? The height of the graph in blue encodes the slope of the graph in red. That's a really advanced topic for this point in the class, but I just wanted to introduce it a little bit so that you can start to see the power, how much information is encoded in this machine right here. How much you know about this machine based upon this machine down here.